All right, hello Math 20-1 students. So today we're going to be looking at getting started on quadratic functions. So that's chapter 3, which is unit 3 as well. So I have kind of like the basic overview of what you should be looking at doing for this chapter here. So 2 days starting with this first part, 1 day on 3.2, 2 days on 3.3, and then I've given you some time for review and the exam. So basically this lesson, the 3.1 lesson, I'm going to break up into 2 different video lessons. Okay, so there's a few good kind of like definitions to know before the unit starts. Some of them, like relation, you might not hear so much, but it's just good to kind of be aware of what it is because it'll just help you to understand functions, which we'll be working with quite a bit. So what is a relation? Well, it's basically just a collection of related numbers. And so if you think about what you know about how to do a graph, you know that if you have an ordered pair like we have here, then the first number is giving you the x-coordinate on the graph, and the second number is giving you the y-coordinate graph on the graph. And so basically, there's a relationship between those two numbers, right? For whatever particular graph you're looking at, those two numbers are connected with each other. Sometimes you can express a relation using an equation. So for example, if we look at this relationship, the relationship between those numbers can be represented using the equation y is equal to 2 times x plus 3. And we can basically see that because if you put in the values, then you should get that number. So basically, if x is equal to 1, we would substitute a 1 in where this x is. 2 times 1 is 2 plus 3 is 5, which is equal to y. And that's what we see in our ordered pair. So you can see how the equation can basically help us to understand the relationship between these numbers. So then how does that relate to a function? Well, a function is basically a relationship or a relation where any one number that you put in, say for the x value, can only result in one possible output number. So in the example that we just looked at where we put in a 1 here and we got out the 5, that's the only possible output we can get if x is equal to 1. Right, and so that's basically what a function is. You put one number in and you can only get one other number, and most of the time we're going to be using that to help us to find different spots on graphs. Now, when we're expressing a function, sometimes you'll notice that we'll replace y. So here where we had y equals 2x plus 3, we'll replace it with f of x. You don't have to, I don't know, for some reason this freaks students out, and I think it freaked me out when I first, did math when I was younger as well. But all it's saying is that still here you can calculate a y value, but this is basically saying that y value is a function of the value of x, right? So it's determined by whatever value you put in for this variable, okay? So getting even more specific, what is a quadratic function then? Well, a quadratic function is one where the value of f of x is given by an equation that includes x squared. Okay, so a quadratic function is just a function where you have an x squared value in it. The simplest possible version of that is just f of x is equal to x squared. And so that would basically be where your y value is going to be whatever number of x you have squared. And then just some stuff like we're going to look a little bit more at an example of what a quadratic function is in a minute. So if that doesn't totally make sense to you yet, we'll get to it, and hopefully when you see an example, it'll make more sense. Then we also have the vertex here, so just some graphing terminology that you should know. The vertex is either the maximum or minimum point of a quadratic function. So when we graph quadratic functions that have this x squared value in them, they always have this parabolic shape. Okay, so basically it looks like a U, or in this case, I don't know, maybe like a little n. So when we think about the vertex is always going to be if the parabola opens upwards, it's going to have a point where it hits at the bottom before it goes back up. So that would be its vertex. If we have one that opens downwards, then when you hit the top just before you turn around and start coming back down, that's going to be the vertex. And so depending on which way your graph opens, up or down, you're either going to have a minimum or a maximum, which is basically just the lowest or highest point on the graph. So if your graph goes down, this is going to be the minimum value, right? Because every other value on the graph is above that. And if your graph opens downwards so that it comes to a peak at the top here, then it's going to be a maximum value, right? Because every other value is lower than that. Okay, and then the last thing we have here is a line of symmetry. So you'll see this come up quite a bit. So basically a line of symmetry is a vertical line that splits the quadratic in half. So essentially, like if we were to look here, it looks like this line here. I'm just going to grab a ruler here real quick so that I don't make a mess of this. It looks like this line here probably lines up as being about the middle of this particular function, right? And so you can see that we can draw this vertical line or line of symmetry, and it basically makes a mirror image of the parabola on either side. Okay, now a lot of times what we would say if we're asked what the line of symmetry is, we give an equation. So we would say like x is equal to, in this case it would be negative 1, 2, 3, 4, 5, 6. So x equals negative 6. And so basically what that tells us is if we wanted to draw the line of symmetry, we could go to any y point on the graph and put in negative 6 as our x value, right? So here we're at this y value, here we're at this y value, here we're at 0 for y, but no matter where we are on the y-axis, we're always at negative 6 on the x-axis. Okay, and so we can give this kind of equation basically for the line of symmetry, which is nice and simple. Okay, so let's try an example here. So it's asking us to graph the equation y equals x squared. So remember, that is the simplest version of the quadratic. And we're going to use a table of values below. So basically, we're given our x values. We need to solve for our y values. And so, let's see. We basically have, if x is equal to negative 3, essentially what you would do to solve for your y value is just plug in negative 3 to your x value, right? So negative 3 squared is going to be equal to 9. Okay, now the next one we could do, y equals, we're given x as negative 2 squared, and that equals 4. Okay, so we have 9, 4, negative 1 squared is going to be 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Okay, so we have our values. So basically you could keep on doing these calculations if you needed to until you get to the end. But because these are pretty straightforward, we could kind of just do them ourselves. So now that we have that, we want to graph this equation. So usually with a parabola, I find it's easier to kind of start in the middle. So where the two values are the same, we have 0, 0. So that's going to be right at the origin. Okay, so that's a good word to kind of keep in mind as well. Where the x and the y axes cross, we call that the origin. Okay. So we have 0, 0. Then we have if x is negative 1, y is equal to positive 1. So we have a point right here. And then if x is equal to positive 1, y is equal to positive 1 as well. So we have kind of a mirror image spot there. Then the next thing we have, if x is equal to negative 2, y is equal to positive 4. So 1, 2, 3, 4. So we have a spot right here. And we're going to have the mirror image over here as well, because when x is positive 2, y is still 4. Okay, and then for our last one, when x is equal to positive 3, y is equal to 9. So we had 4, 5, 6, 7, 8, 9, and it's one further out. So we have another point there, and then we're going to have a mirrored point here as well. Okay. So there's our graph. We can kind of connect the dots if we want, which is always my worst part. It's always hard to get it to look nice. Okay, so that's roughly kind of what our graph looks like. Now the next thing says find and label each of the following on the graph. So the first thing we want to find is the X-Intercept. So remember, that's where does this graph touch the X-axis or cross it. So in this case it doesn't go below the X-axis, so it's not really crossing it, but it does touch it right at the vertex here. So remember, the vertex is the very tip of the graph, and that point right there is 0 on the X-axis, right? It's 0 here, and it's 0 on the Y-axis. So we can say 0, 0. So for all of these things, you're always going to want to use an ordered pair, and remember that in an ordered pair, you always give the X value first and the Y value second. Okay, what about Y-intercept? So where does it cross this axis, your vertical axis? Well, same thing, basically, just at 0 and 0. Next thing it wants, what is the minimum value? So if we look at this graph, the lowest point that it gets is 0 on the y-axis and 0 on the x-axis. So the minimum value is found at 0, 0. What about the maximum value? This is a little bit trickier because even though we stopped the graph here at 9, usually with these kind of graphs we know that you could keep making this series go infinitely. And so essentially what we say for the maximum value is that it is infinite, right? There is no maximum. Okay, then a couple of other pieces of terminology that you might have to remember from previous math. Domain. So remember, domain is all possible x values. All possible x values. And we have a bit of a weird way of writing this. So typically you would put the domain into these kind of curly brackets. And for this particular one, what could our possible values of x be? Well, if this graph keeps on going indefinitely upwards, then the parabola is going to continue to expand outwards. So x could possibly be any real number is what we say. And we represent that by doing this little kind of weird e. That's x can be any real number. Okay, so the R stands for real numbers. And then we also have range. So all possible, you can probably guess what this is, y values. Okay, so again, we do our kind of curly bracket. Now with the y, it's a little bit trickier because the y can continue to go up into infinity. So you might think it's just going to be y is equal to all real numbers. But there is one limitation, which is that because the graph kind of stops here before it turns back up, it can't be lower than that point. So we actually have to make two statements for the range, which is that y has to be greater than or equal to 0, right? So it was 0 here. And we can also say y is equal to all real numbers. Okay, so we're giving a qualifier. It has to be greater than 0, but other than that, it can be equal to any real number. Okay, what about the vertex? Well, the vertex is that minimum value, which was 0, 0. And what would be the equation of the line of symmetry? So remember, that's the vertical line that divides this graph in half. And that vertical line is at what point on the x-axis? Well, because it's right at the origin, we can say x is equal to 0 for the line of symmetry. Okay. So hopefully that kind of helps you to get a basic understanding of what our general quadratic function will be. And now what we're going to start looking at is specifically this thing called a vertex form. So if you remember from Math 10, you would have looked at the standard form. Can you remember what the standard form is? Y equals mx, or sorry, not mx, ax squared. There we go. Ax squared plus bx plus c. So you would have looked at that form before. So this is going to be a different form of the equation. So we're going to have, similarly to what you would have seen in the standard form, we're going to have different numbers that can be in the equation that are going to change the way the graph appears. Okay, so we're going to figure out what this vertex form is at the end of this lesson, basically, but we're going to look through some different examples at what the different values that we're going to add into this equation are going to do to the graph. So starting out with this part here, it says using a graphing calculator, sketch the following. Okay, so we're given a whole bunch of different y equals here. So it is important for you to have a graphing calculator for Math 20-1. I would recommend that you get a Texas Instruments one because that's what I'll be doing everything on. You don't have to get the same model, but the buttons will be the same no matter which model you get. So if you want to get a little bit of a cheaper model, that's totally fine. I needed this one because it shows up a little bit better on my camera for you guys. But you'll definitely want to have something like this, and it's easiest if you get one like this because then all of my instructions will work for your calculator. So if you want to type in y equals x squared, you just go to the y equals and you're just going to put in, this is our x button right there, so x, and then we're going to square it. Okay, now if I want to see the graph of that, I'm going to go hit graph, and this graph shows up right there. Now, if you get a weird zoomed in version of this, you can go to zoom, and you can go to number 6. So you can actually just press number 6 on your calculator if you want, or you can scroll down and hit enter. Either one will work, and then it'll automatically kind of zoom it to a more standard setting for you, like window setting basically. Okay, so this is our y equals x squared. So you can see that it's just kind of this basic kind of U shape, right? Now let's see how it changes if we say y equals 3x squared. So we go back to y equals and we clear it out and we can hit 3x squared, and then we can go to our graph. So if you look at comparatively, now I know my drawing isn't going to be a perfect representation here, but comparatively what we see here is that the 3x squared is actually narrower than this one was. So it's a little bit more like that. Okay, so it's a little bit narrower. Now, based on that, what do you think might happen with 5x squared? You can probably guess, but let's have a look. If we graph it, even narrower, right? You guys are going to have to bear with me because I just find drawing these graphs really painful. Okay, all right, so that's narrower. Now, what happens if we go to a quarter x squared? So as our numbers have been getting bigger, what have you seen happening to the shape of the graph? It's getting narrower. So what do you think is going to happen if our numbers start going smaller, right? Like into decimal numbers. So maybe take a guess at that, and then we'll see what happens when we put it in. So for this one, what I'm going to do is 1 divided by 4. I'm going to put it in brackets, x squared, and then I'm going to hit graph. So hopefully you were able to guess that. If the numbers were getting bigger, we saw that the graph was getting narrower. So now when we make our numbers smaller into decimals, we see that the graph becomes quite wide. Oh boy. Okay, good enough. Of course, that was meant to be on the vertex, but you guys will just have to be a little bit creative with your interpretations of my drawings. Okay, good enough. Now, what happens if we make it into negative x squared? Okay, so we've gone smaller. Now technically a negative number we kind of usually think of as smaller, but I'll give you a hint, that's not exactly how it's going to be interpreted in the graph. So see if you can guess what you think is going to happen there. Sorry, negative x squared. Now keep in mind, if you're ever putting negatives into your graphing calculator, you have to use this button, the negative button, not the minus button, okay, because this in the calculator only means subtract. So if you put that in, you'll get an error if you're putting it in trying to be a negative. Okay, so negative x squared, and let's go into the graph. Okay, so we basically see that it's similar shape to the x squared one, but it's flipped upside down, right? And that's actually what a negative value does for us, is it flips our graph so that it opens downwards instead of upwards. Okay. All right, now what do you think is going to happen if we do negative 10x squared? Y equals negative 10x squared. Graph. And hopefully you could guess that. So the bigger the number is on the negative side, it still has the same effect. It's still becoming narrower. So we're going to do super narrow. Okay, now what if I do negative a quarter? I'm sure you can guess this. Negative 1/4 x squared. And you can see, so the effect is still the same. If we have kind of a decimal number, but it's in the negatives, it opens downwards, but it becomes wider again. Okay, so we've kind of seen these general trends, and so later on you're going to find out what this value means in the terms of the vertex form. But for now, let's say if we have a graph y equals ax squared, so a is being multiplied by the x squared value, then our kind of like what we call the mother graph, the y equals x squared, is going to be transformed as follows. So if our a value is greater than 1, what happened? Well, we had 3 and 5, and we found that the graph got narrower, right? Sorry guys, I just realized I'm missing something here. Okay, there we go. Okay, so the graph becomes narrower. Now, what about if a is between 0 and 1, right? So if it's greater than 0, less than 1. And actually, I should kind of make a qualifier there. Or if a is, let's see, how would I write that in? Less than, if a is, there we go, greater than -1. Oh, I put those in the wrong way around. Or if -1 is less than a, and a is less than 0. So basically if we have a negative decimal like we had here, so -1/4, the graph becomes wider. Okay. Now the other thing is, if a is less than 0, so basically if it's a negative number, what happens to the shape of the graph? Well, the graph flips upside down. Upside down. Right, so we see that it opens downwards instead of upwards now. Okay, so let's try some practice. We want to actually sketch and analyze a quadratic function that has an a value attached to it. So we have y equals negative 0.5 times by x squared. So first of all, we can try and figure out some stuff. So what do we think the y-intercept would be? Well, just like all of these other ones that we did here, our intercept is going to be at the origin. Okay, so this is going to be where we're going to start out. So our y-intercept is going to be 0, 0. Our x-intercept is going to be the same. So our vertex is, for all of these ones, was at the origin. So we can say 0, 0. What are the coordinates of the vertex? Well, the same thing, because that's the point that we start from. So that's 0, 0. And what would be the equation of the axis of symmetry? Well, with this graph, we're going to be going, or if our vertex is on 0, then we can say the axis of symmetry is going to be x equals 0. Do we have a maximum or minimum value? So this is where we need to start looking at sketching the graph to figure this out. Y equals negative 0.5 times by x squared. So what does the negative tell us about the shape of the graph? Is it going to open upwards or downwards? Well, negative, we just determined, opens down. Okay, so the negative means that it's going to go down. What about the 0.5? What does that tell us? Well, it tells us that we're going to have a wider graph than just x squared. So basically we can kind of go, our graph is going to look something like that. Okay, so it's a little bit wider, it's pointed down. So now we know that the vertex is a maximum value. Okay, so max is going to be 0, 0. Okay, we don't really have a minimum value, although you could just put down minimum is going to be infinity. Okay, what about the domain? So remember, the domain is all possible x values, and we do those kind of squiggly brackets to show that. So we would say x. What happens with x? Is there any limitations? It starts at 0 and it moves out to either side from there. So again, we find that x can be equal to all real numbers. Okay, what about the range? Well, the range is all y values. We can start out with our squiggly brackets. Now, remember that with the y values, because it can't go above the maximum, we say that y has to be less than or equal to 0. But other than that, y can be equal to all real numbers. So we can add that qualifier in as well. Okay, and that's our first graph. So now let's have a look at another value that can affect the shape of our graph. So in this one, we're going to do the same thing. Use a graphing calculator and sketch the following. So y equals x squared. I'm just going to sketch this one in because we've looked at that a couple times now. Okay, so that's approximately what y equals x squared looks like. Now let's go to y equals x squared plus 3. X squared plus 3. Okay, and let's look at the graph. So how does that look different from the first one? Well, you can see that our vertex for the first time is not sitting on the origin. It's shifted where? It's shifted up by 1, 2, 3 units on the y-axis, right? So we can see that it's, if we imagine that that might be part number 3 or point. Sorry guys, microphone just cut out there. I'm going to try and redraw that a little bit better. There we go. Okay, so we still have the x squared shape, but the whole graph is shifted up a little bit, right? Now what about here? We have y equals x squared minus 1. So just think for a second maybe, what do you think is going to happen there? Y equals x squared minus 1. And so we see now that the origin, or that the vertex rather, is at -1 on the y-axis. And so the rest of the graph looks the same. It's still pointing upwards. So we can sketch it basically the same way, but we're just going to start it just a little bit below. Okay. So there's our last one. So now what can we say in general if you have a graph of y equals x squared plus q, right? So before we had ax squared, so a number that's multiplied by the x squared value. Now we have a number being added to or subtracted from the x squared value. So this is a change to our y equals x squared graph, right? So what happens, how does it move up q units if q is positive? Right, so whatever the number value is for q, in this case it was 3, and so that means that our graph moves, like the whole graph shifts up by 3 units. When q is positive, it moves up. Okay. Okay, so, and then if we have q is a negative value, then it's moving down, right? So it moves down q units if q is negative. Okay, so basically this is the second way that we're going to see that these graphs can be altered. So let's apply that to an example. So it asks us to sketch and analyze the quadratic function f of x equals x squared minus 4. So basically we have x squared minus 4. So what does this minus 4 tell us is going to happen with the graph? Well, based on what we just saw up here, this is a q value, and so we know that it's going to move down 4 units. Right? So where we normally would expect for an x squared graph for the vertex to be at 0, 0, now it's going to be at 0 still on the x-axis, but -4 on the y-axis. Okay, so that's going to be our vertex. So where is our y-intercept? Well, it crosses the y-axis here at 0 and -4. Okay, what about the x-intercepts? Well, it's going to cross the x-intercept at a different place, so we're going to have to figure that out. So basically what we can do is, for these ones, I'll show you guys how to do this manually a little bit later on, but if we wanted to go into our graphing calculator, we can fill in our value, x squared minus 4. So x squared minus 4. Go to our graph. Okay, and so basically what we would do here is say, if we want to figure out the x-intercepts, it's where is it crossing. Now you can probably see actually from this one that it's crossing at 2 on the x-axis, but if we want to be really careful to make sure we're being exactly right, you can hit the trace button. Okay, and wait a minute. There we go, sorry, second function trace, and then you want to hit 0. So then it'll ask you this question, left bound. So basically that means you want to go to the left side of whatever target you're trying to get. So we want to know where it crosses the x-intercept. So as long as you're to the left on the graph of that, you should be fine. So you can hit enter. Then it asks you right bound. So I'm going to go to the right side of the graph of that point and hit enter. And then it asks you guess. So you have to hit enter again. And then it gives you, so when y is equal to 0, x is equal to -2. Now if you wanted to, you could do it again for the second side here. So you could go, it's going to ask you left bound again, so you want to go kind of close to the intercept, hit enter, right bound, go to the right side, oops. And then it'll ask guess, and we can see that it's 2, x equals 2 and y equals 0. So it's that mirror image that we expect to see. So we can say -2, 0, and 2, comma 0. Those are our x-intercepts. Okay, so if you need to remember in the calculator, you basically hit second function and then trace, and then 0 is the one that you want to choose. And then you just have to follow the instructions that it says on the screen for left bound and right bound and all of that. Okay, now what about, now that we know our x-intercepts, we know we're going to be at -2. So maybe like there, let's say, and -2, or +2, sorry. So now we kind of have a little bit of a better idea of how this graph would be shaped. Okay, so there's our graph, and then let's see, what are the coordinates of the vertex? That's going to be the same as the y-intercept, 0, -4. What is the equation for the axis of symmetry? Again, it's centered around x on 0, so we can say x equals 0. And in this case, it's going to have a minimum value of 0, -4. Okay, now we can, of course, say, oops, maximum would be infinity again, right? Because it goes upwards indefinitely. Domain, what are all the possible x values? X, again, can be all real numbers, so hopefully you're becoming familiar with that by now. What about the range? Well, y has the limitation that it doesn't go below this point, which on this graph is -4. So we can say y has to be greater than or equal to -4. And y is equal to all real numbers other than that, right? So when it goes up from there. Okay, so now we have seen A and Q, how they can affect the graph. Let me just see here. I think I'm putting my papers off in weird places. I don't want to lose them all. Okay, yeah. So the next one is going to be looking at okay, so this is our last one here, and this is going to be looking at something called P. So again, we're going to start out with our basic graph, y equals x squared. So kind of like that. Now let's try putting in these different ones. So again, we're going to go into y equals, and in this case we have bracket x plus 1, close the bracket, and then hit squared. And if we go to our graph, so hopefully you can see what the difference is here. Before, when we had A, remember it would have just been multiplied directly by this x value. When we had Q, remember that it would be outside of the squared. So this doesn't count the same as Q because now we have something that's being added to x in this case within the squared. So both of these things are being squared. So it's a little bit different from the last example that we saw. So if I graph this, what happens? Well, you can see that the origin is no longer the point of the vertex. We have the vertex shifted to the left, and the vertex is sitting right on -1 of the x values, right? So let's just say that this is -1. And then we kind of see the graph going like that. Okay, so basically we've seen that if we have x plus 1, we have to move our vertex to x equals -1. Okay, what about x minus 3 squared? So y equals x minus 3 squared. You can probably guess what's going to happen here. We see that the vertex is now at x equals +3, still y equals 0. So if we move this one out here, okay, so basically what we're doing when we have these different graphs where we have values being added to or taken away from x, the general form that we would write this is in y equals x minus p. Okay, so p is our number value, and in the equation we're always saying minus. So if you think about what we talked about here, that this is now at, let's see, on the x-axis, -1. So we have our x value is -1. Why do we end up with +1? Well, if the formula is x minus whatever value, which in this case was -1, x minus -1 is equal to x plus 1. Okay, and so that's why we see this in our formula, even though we're using -1 on the graph. What about over here? We have x minus 3. Well, and our point here is +3 and y is 0. So again, if we're using this formula, x minus +3 is equal to x minus 3, right? And so that's why we end up with the opposite values, basically, of what we would expect given where the graph moves to. So we can say that when we have this version of y equals x squared, then the whole graph is going to be translated to the left by however many units p represents if p is negative, right? Okay, and we're going to move to the right by p units, right, if p is positive. Okay, and so again we can kind of say that it's because x minus -p is equal to x plus p, and x minus +p is equal to x minus p. Okay, so that's where we get the kind of difference in the numbers. So let's try an example with this one really quickly as well. So sketch and analyze the quadratic function f of x is equal to x plus 4 squared. So given that the only change we have here is that we have a p value added in here, so x plus 4. Now, if we were to do this as x minus, right, the way we should, what would make it into +4? Well, it'd be if we have a -4 here, equals x plus 4. Okay, so we know that our x value is going to be -4, so let's just maybe make that our x value. So we're going to have -4, 0, and for the rest it's going to go up from there because we don't have any negative a value out front there. So -4, 0, we know it's going to go up, and so we can say the first question is asking us for the y-intercept. Now this is a little bit tricky, and we haven't done anything like this yet, because basically where is it going to cross this y line, right? It has to go way out and reach over to there. So we know it's not going to be at 0 like we've had a lot. And so if we want to go into our calculator, we can go to y equals, and we can do x plus 4 squared, go to our graph. Now you can see that it doesn't show up on here really well, so actually normally you would have to reset your window settings. So let's maybe make our y maximum, because 10 isn't high enough, right, as we can see. So let's maybe make it 20 for now, and then go to our graph. Okay, see, and now we can see where it's crossing over there. Now, I mean, technically for a graph that's this simple, you could just count them, but if we want to be really specific, we can again go second function trace, but this time instead of hitting 0, we want to hit value, because this means we can put in, if x is equal to something, what would y be equal to? And we know that at the y-intercept, x is always 0, so we can say x equals 0, enter, and there it shows us when x is 0, y is equal to 16. Okay, so that's where it's crossing over here. So basically we would see that this graph is going to go something kind of like that. Okay, and let's just say that this point here is 0, 16. Okay, so that's going to be our y-intercept. 0, 16. So if you need to remember how to do that on your calculator, you're going to go second function and then trace. And then you're going to enter value, which is the first choice there. And then you have to enter in for x equals, you need to put in that x is equal to 0 for a y-intercept. Okay. X-intercept, well, that's right where the vertex is, so we can say it's -4, 0. What are the coordinates of the vertex? Same thing, -4, 0. The equation of the axis of symmetry. So remember, if we were to draw a line that cuts this thing in half, then that line would be located on x equals -4 the whole way. So we can say x equals -4 for our axis of symmetry. What about our maximum or minimum values? So in this case, because it opens upwards, our minimum is going to be equal to -4, 0, and our maximum is going to be infinity. What about domain? So what could all of our x values be? So x is going to be equal to all real numbers again. Barely even have to think about that one anymore. And then our y values are going to be greater than 0 or equal to 0. And again, y can be equal to all real numbers. Okay, so that is basically all the different components that we're going to be incorporating into the vertex form. And so here you can see we're going to go a step more complicated, and we're going to put all of those things we just learned together. So we have f of x is equal to 2 times by x minus 3 squared minus 4. And we're going to be asked to solve for a bunch of things just like we've been doing up until now. So we want to think about what is all like told to us basically by this equation. So if we have 2x minus 3 squared minus 4, what does the 2 tell us? So it tells us the shape of the graph. So remember, positive and negative tells us which way it opens. 2 tells us whether it's getting wider or narrower than just x squared. What about -3? What does that tell us? Well, it tells us the x value of the vertex. So vertex x coordinate, maybe is the better way to say that. Okay, and then which we call P in our kind of traditional format for this type of an equation. And what does the -4 tell us? Well, it tells us the vertex y coordinate. Vertex y coordinate, which if you just see the graph or the vertex form of equation in general, we call that Q. Okay, and the shape one is our A value. Okay, so now that we know that, we can see right away that we already have our vertex coordinates, right? We see that the vertex is going to be at a value of 3. Now remember, because it's -3, that means that our actual value is going to be, for the vertex, is going to be +3 for the x value. And for the y value, we keep it the same, so it's going to be -4. So we can go +1, 2, 3, and -1, 2, 3, 4. Oh shoot, I just lost that. 1, 2, 3, 1, 2, 3, 4. Okay, so that's our vertex, right? Now the other thing we can think about is, oh, you know what? Actually, though, we're going to have to figure out, because this is going to have a weird y-intercept. So before we sketch this, let's figure out our y-intercept. So let's see how far we can get with this. So the first thing we're asked for is the vertex. So vertex is, like we just said here, it's at +3 on the x and -4 on the y. Okay. So let's see what else. Domain and range. So domain is going to be our x values. Now the one thing we know before we even sketch it is because this is a positive value, it's opening upwards. And so that means for our x values, it's going to be still all real numbers, no big change there. But for our range, we're going to say because it opens upwards, it's going to be y has to be greater than or equal to this bottom point, which is -4. And then also we can say y equals all real numbers. Okay, so that's domain and range. What else do we have here? Direction of opening. So A is equal to +2, so opens upward. Okay, what else do we have here? Axis of symmetry. Well, it's going to be right along this x line, which was +3. So because P equals +3, so x equals 3 is our axis of symmetry. What else do we have here? Okay, now this is kind of new information, is the Y-intercept. So I told you guys how to figure it out in your graphing calculator, but I also want you guys to know how to do this manually. And so basically what you would do to solve for this is whenever you have a y-intercept, just like we said in the graphing calculator, your x value is going to be equal to 0. So if you want to solve for it, you can basically just take your equation, because f of x is also y, right? So we can say y is going to be equal to 2 times by, in this case we're saying x is going to be equal to 0, and then -3 squared -4. Okay, so you're just taking the formula you were given and plugging in the x value to find for the y-intercept. So now we're going to say, okay, y is equal to 0 minus 3 is -3. And if we square -3, we get +9 minus 4. 2 times by 9 is going to be 18 minus 4. And so we can say y is equal to 14. Okay, so now we can say y-intercept is equal to, it's going to be x is 0 and y is 14. So that's what we would want to give as our final answer there. So now that we know that, now we can sketch our graph. So if the y-intercept is going to be at 14, I believe this goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so this would be 10, so it's going to be like up here somewhere. So that's going to be like where it crosses, somewhere up there. So I mean, this is just going to be a rough sketch. Let's go. There. Good enough. Okay. So that's kind of roughly what the graph is going to look like, and we can always put in here, we have 3, -4 as our vertex. And so that's our introduction to quadratic functions. And that was a really long lesson, so it's a good thing I broke this into 2 parts. So next time we're going to keep on going with this. We're going to look at doing a little bit more complicated of calculations with this material. So in the meantime, you can try this practice assignment here on page 157, and I will see you in the next lesson.